it's been yeah, 7 last week. So I think with summer around the corner, get ready for finals and stuff like that. It's
And 2 weeks to the golf match.
what's that?
I was in gone last week.
Yes, yeah, that's what I'm seeing, like track events and
Yeah.
stuff like that. It usually is. And it is the time of year. So we're talking about how we want to do this next year. I don't know that I'm gonna teach a heck. I'm gonna see if I can talk to someone on or get somebody else up there maybe to volunteer and teach the golf school, because it is a huge commitment. Or we could just do a weekend, which would really be massively intense. It'd be 2 8-hour days, and you're just going to be, there's not going to be any time for what's that? Yes, yeah, and it's one of those things. I mean, it's you can do it, but it's there's going to be no time. It's just go through it, and what I like about this format is we can have discussions, talk. You guys ask questions about something. 9 times out of 10, somebody else in the class has the same question, but they're just not asking. That's the only drawback to those short format training sessions. But and it might might be an option there. So, or we might go to just more of an information course, and we don't do the ground school. We'll see. We'd have to see. I mean, like you, obviously, and Joel, I know you're going to get your license. But I think some of the students that are here just more for information, they're curious about aviation. So for them, it's not ground school. A lot of the details that we get into in the training. But I guess we kind of do. Yeah. We delivered 3 flight simulators this week. To Wyoming Fremont, Appleton School District in Janesville. And Messina is getting your simulator next week sometime. And after that, oh no, I think it's the process that's one next.
Do you see the huge thunderstorm?
Yeah, it would move through fast. Did you see that it was a line of thunderstorms that through? That's a good time to hone your weather skills, is to go online to sites like this and look at the weather charts just to see what it looks like. How might you get paid?
Well, we went down to Bearwood to get some food, right? 10 out of 10. And then this is like the storm was chasing us the entire way.
Oh wow!
Down from the Dells all the way to Bearwood.
I want to see the or the Alice, whatever it's called.
Oh, seriously, there was?
Yeah.
This last night?
Yeah.
Oh, God, they did it. Was it pretty intense?
It's like my mom got a picture of and had like a small bit.
Oh, wow, that's spectacular. I wonder, yeah, they did say they were going to be a bunch of CMEs that
Player.
Yeah. Hey, Max. Yeah, that, shoot, I wish I would have known that up middle of the night. So usually I'd be outside of it. Nice to see that. It might still be around tonight. They did say that the sun is really active right now. There's supposed to be a bunch of CMEs in the course of the day. So, wait, Colin, yeah. So did you get my email about the medical examiner?
Yeah. Okay, good.
Yeah, he's a real good guy. Real sharp. He's, I think, ex-military and just very down to earth. I think that's the one. Jace, did you go to him, Anderson, in Littleton for your medical? Yeah. Well, good. Does anybody have any questions while we got some time? Before we get started? We're just finishing up on one of this week. We're going to do 2 more chapters. One is on airport operations, and then the other is on airspace. And then last week will probably be our last week. We're going to cram in a ton of stuff. So we're obviously not done. I still have to get you guys your student pilots certificates. I got to get you registered, all that. That we can do one-on-one. I can have you guys come out to the office there and get all the paperwork done so that you get your student pilot's license. And then the other thing is scheduling time to fly for your first flight. So right now my schedule is we probably won't be able to do flights until we get into June. If I can do something earlier with this month, I'll try to work around your schedules. My schedule is kind of bizarre. I get up super early in the morning, like midnight, and then go to work. So I don't really go through much after 4 o'clock. So if you have time in the morning, we do our flights and stuff. So, and I do occasionally fly to client sites. So I'll let you guys know if you guys want to ride along. Get an idea that we keep flying between. So. All right, Johnny, how you doing?
Good.
No questions at all? You guys are.
So we're finishing with our
Airport operations and then airspace. So one of the things you might want to do is get out your Seattle sectionals. And when we get into airspace, we can go through that. Morning. How are you doing today? Pretty good, everybody. Doing well. Doing well. And we're on page 13, chapter 13, page 18. All right. It's a little early. Why don't we just go ahead and get started? And maybe just wait just a couple more minutes here. Do you guys remember all the weather symbols, the all the different front symbols and stuff like that? You guys remember this one? Yeah, well, you can see it right down here. So does anybody remember what I used as a memory mnemonic for front fronts? What's that? Yeah, blue. Yeah, kind of. You think of blue, you think of tolls, and red is typically hot. Yep. That's if they're color coded. But a lot of times in some charts they're just black and white. But the little triangles here, just think of them as teeth. So it's biting cold on there. So that'll help you distinguish between cold fronts. This right here, obviously, is stationary front. Notice how the barbs are in different directions here. That's the difference between a stationary front and an included front. So an included front is one where you've got, let's just see if I can find one, where you've got two fronts. So like what's happening here, this is a really complex diagram. Let me zoom. So what's happening here, there's the winds here are pushing this cold front around. It's wrapping around this way, okay? And what it's doing is it's hitting this warm front right here, and it's creating an included front right there. So the cold front actually, because the colder air is denser, it actually flows below the front there. So, morning, how you doing? So, and you can see here's another included front right here where there's two fronts that are slamming into each other. And this is, like this front right here is moving slower. This one's moving faster and it catches up to it. And the cold actually, so if you've got warm front, warm air here, you've got cold air and it's moving toward that warm air. Because the cold air is denser, slides underneath the warm front. And you also have situations where you've got a warm front here, let's say, and a cold front here, and the warm front moves this way. And again, warm air is lighter, right? So just like hot air balloon rises, so it's going to climb over that cold front. So that's the situation. That's an included front as well. So that's the difference between stationary fronts, the symbol right here, and the excluded front. And you can see it's got the combination bars. Notice there's no colors here. It's just one color. So a lot of times you'll look at aviation charts or like weather maps. They won't show colors for the maps. It's just the symbol itself. Again, the mnemonic that always uses the cold fronts are inviting cold. Okay, so here's all the different front symbols. You don't have to know all of these. The primary ones are these up here. So the cold fronts, warm fronts, stationary fronts, and included fronts. Let's see here. Yeah, these are less. This has to do with the front generation of fronts, and then you're not going to see them on the test, the FA test there. Trough, all that is it's just an area of low. When you think of trough, you think of something that's deep. It's like a feeding trough or something like that, so it moves down. So we associate troughs with low pressure. So you might see a line. Well, that's just a line of low pressure. That's all that is. Here. Dry line again. At squall lines, we do, obviously you want to be aware of what a squall line is. A squall line is a fast moving cold front, and usually the leading edges of fast moving cold fronts, especially if you have that water vapor in the atmosphere and you've got instability in the atmosphere, you're going to get thunderstorms. Now this last week, we were just talking about it. There was a squall line, very weak squall line that moved through the area here. And all along, if you were to actually look at the weather map, and I encourage you guys to do this, look at a radar map when we have weather moving through, so you got to get familiar with how it looks like. But what happens is on the leading edge of the cold front, it's pushing up all that air, and it's creating instability in the atmosphere. Because you've got cold air moving over the warm, damp air, it's creating these thunderstorms, and that's what happened with the squall line. This last week. So some squall lines can generate massive weather. I mean, it's just a line of lightning. There's a couple of good websites you can go to. I think WeatherBug is one of them. Weather Underground. Those are good sites to kind of get familiar with how weather works. So, right. And remember, we talked about isobars. You guys are comfortable with that. If you have any questions on it, let me know. But the more isobars you see in an area, the steeper the change. So here's the low pressure. So that would be like a valley right there. This right here would be a valley. And then it climbs up, and here we see it. This is probably a high pressure area right there. So yeah, this is the pressure is going up here. You see the middle bars it's showing all the pressure is increasing there. So it's going from a valley here to a peak over here. So that's how they describe low and high pressure. Here's a high pressure peak right there. And then from there, it kind of goes down into a valley here to this low pressure area. And then you can see the fronts moving. This is a surface analysis chart. Surface analysis charts are generally used for doing long range planning. If you want to see current conditions across the U.S., if you're across country, you kind of get an idea of where the weather is going to be. So stationary fronts can produce some bad weather. They're not the best weather to fly in. Cold fronts, if you stay on the backside of them, you're typically really good. Cold fronts can generate massive bad weather as they're pushing through, especially if they're fast moving cold fronts, because you're going to get that. Like down here, we've got the maritime air moving up from here, which is very moist. Again, as the air mass moves over a surface, in this case the ocean right here, these oceans here, they're sucking up all that moisture to bring it in them, and then it hits that cold front. Matter of fact, whenever we have a major blizzard or something like that, it's usually because we've got this maritime air moving up with that laden, water. It's just got lots of water. When that cold air hits it, it just instantly condenses into, snow, rain, or something like that. So, so obviously, if I was doing a flight today and I had to go here, I would either try to fly over in this direction over here and then down. Anyway, well, it depends. If there's not much moisture, this, this is just a symbol. It's just a change in temperature. But if the conditions are right, you've got a lot of moisture here and instability in the atmosphere, then I'd probably avoid, flying through that cold front there, because that could get small line thunderstorms, things like that. There's obviously other charts that we can use, but this is just kind of a high level overview. Here's a low level. This is that trough I was talking about. So this is a low pressure trough, and you can see you've got two low pressure systems. So it does go up a little bit here, but this is still low in this area relative to the high pressure up here. So, any questions? Good. Let's see here. Oh yeah, then I want to talk about some of the symbology they use in some of the maps that you'll see online. So this is like an airport, designated for an airport reporting station. We know what this is right here. This is the wind speed, wind direction, and wind speed. So this is telling us that the wind, just like an arrow, when you look at an arrow goes this direction, it's pointing this direction. You've got two wind barbs here. The longer wind barbs are going to be 10 knots. So this is telling us that we've got basically 20 knots of wind out of the northwest. And then they're going to have the numbers here in the various quadrants here. They all have different meanings here. So you've got your temperature and dew point, and then present weather. In this case, those symbols are for snow there. And then sea level pressure. This is even Mars. Yeah, this is the Mars there. And this is pressure change. It's either increased or decreased in the last 3 hours. So the primary elements that you're going to be interested in are obviously the wind. Look at this map. Actually, let's bring up the map and cast this up. So this is. Yeah, here's a good example. So this is a TAF terminal aerodrome forecast map. So you can see here there's Madison right there. It's Milwaukee, Janesville, La Crosse. They only have, anybody know what that would be? Yeah, about 5 knots. Yeah. And then this is 10 knots. It does say 6+, but if you click on it here, this is what's nice about the web. You can click on it and actually read the tab for that. What's the difference between a TAF and a METAR? Anybody tell me the difference between a TAF and a METAR? What's the primary difference? Yeah.
Isn't one done by an actual person and the others?
That's one difference. Yes. Yeah. Although METARs can be generated by a person. But the big difference between a TAF and a METAR is that a METAR is an observation. It's me going outside, looking at the sky and saying, the sky is clear, the wind is out of this direction. And it's at that point I report it and it's done. A TAF, however, if you break down what it says, TAF stands for terminal, which is like the airport terminals. They go through airports that have control towers. Aerodrome, airport, forecast. So a METAR is an observation, and a TAF is a forecast. So there's a big difference between the two. And you don't want to look at a METAR map and say that that's going to be the forecast, because it's not. It's just observations. You can get an idea of how weather is going to behave if you know where the weather is moving from. So, for instance, if I look at all the winds here, it looks like all of our winds are out of the northwest, which is what they normally do. They normally go northwest. So our weather is moving this way. So if I look at a bunch of METAR reports over in this area, I know that at some point that weather is going to move down to where we're at here. So they can be used as forecasts, but the TAF is, a meteorologist going out, and they're saying they're using their professional skills to determine what the forecast is going to be for up to a 24-hour period. So, okay. Let's see here. Let's go to here. Yeah, they have, these are some different symbols that you see for winds. They're called. Here's another type of symbol that you'll see. Again, they all have the same format: temperature, dew point on this side, and then any weather. In this case, we've got rain here, and the sea level pressure. Normally, this would be this is one of ours here, but I think for U.S., a lot of U.S. charts will have this in inches and there. Let's see here. Yeah, we've seen this before. Through that. This is the weather depiction chart. And what this does is it just tells you where the significant weather is, where the clouds are. In this case, you can see, actually a lot of this, you can look at the chart and you can actually see what it describes here. So in this case, let's see what it was issued at 1842 Zulu. So it's going to be like 9 o'clock. No, 1 o'clock. 1:42. Tuesday, December 15, 2015. Actually, that would be that'd be a new. And it's valid. Here's when you ever see the word valid, it's telling you that it's valid at that time. So it's saying that this map is it's kind of a forecast, and it's going to be valid at 0 Zulu, which is that Wednesday night. For that what the weather should be looking like right here. And they've got fronts in there. They're forecasting like the fronts. It's a warm front coming up here, and then you've got a trough, a low pressure trough here, another low pressure there. But it's generating a lot of weather here, and you can see, you can read these things, the legend down here. So when you're taking the test, don't be afraid to look around a little bit. If you're, one of the things I always tell students, if you're coming across a problem, answering a question, go ahead and mark it when you take the test, and then come back to it. Don't waste a lot of time on one question when you're first taking the test. If there's any doubt in it, just mark it and then come back to it. Get all the questions, as many questions as you can answer and done, and then back and do it. And then what you can do is you can analyze. Have a chance to look a little bit more at some of the details of the charts. So again, there's a lot of information here. They always have this statement down here. It's always going to have an issue date in time, and then a valid time for the forecast itself. In this case, this is a person that generated this forecast there. So, and this is a significant prog chart, for prognostic chart, weather prog. So significant means that it's significant weather. So things that are significant to pilots: icing, severe turbulence, moderate to severe turbulence, and thunderstorms, things like that. So you're going to see a lot of that stuff here. As an IFR pilot, I'm terrified of ice, because I don't have de-icing on board the Twin. So that's something that, if there's, any kind of forecast for icing, I'm looking for alternate methods of getting my destination. So if you've got, icing equipment on board the aircraft, then it's not so much of a problem. It still is a concern, though. There's icing is brought down aircraft that are very well equipped to handle icing, and it still brings it down. Spirits. There's one 20 years ago that it crashed in Indiana. So it's a small commuter turboprop, and it hit clear ice, which was the worst, because it instantly sticks to the plane as soon as it hits it, and it loads it up with massive amounts of weight, and the plane can't support it can't produce enough lift, and it comes down. So okay, so here are a couple things. Again, the legend down here. Again, look at the legend right here. So this red line indicates ceilings less than 1,000 feet, so that's IFR. So this is all IFR up here, and then little squiggly cloud lines right here. Ceilings between 1,000 to 3,000. That's what we call marginal VFR. They're in visibility 3 to 5 miles. So you're going to have low ceilings in this whole area right here. So there's a pretty good system that's in this area right here. I may not be producing really bad weather, but it's IFR, so it's instrument flight rules. You wouldn't be able to go out and fly, especially if you're a student. You're not going to be able to fly in this area right here because that's all IFR. But in this area, you might be able to do touch and goes in a local airport, it's marginal. And I highly, encourage you to go up with an instructor, and fly in marginal conditions, just so you know what they look like, because they can turn into instrument conditions. And then this right here, dash orange line right here, here's the turbulence there, and that's the symbol for is moderate turbulence there. And moderate turbulence is means two different things depending on what kind of aircraft you fly. So if you are flying a light plane, moderate turbulence will throw you, if you're not belted in, it'll throw you up into the top of the cabin. And I've been in turbulence like that, and it's not fun. So, but for an airline, it's not as bad, because you've got big wings, they're flexing and stuff like that. They absorb a lot of it, and plus, it's a heavy object. It's the same difference between taking an empty bread bag or like a plastic garbage bag and holding it out in the wind. If there's no weight in it, it just flops around. The minute you put some weight in it, it becomes more stable. That's kind of what's the difference between a light plane and a big, heavy plane. They're a little bit less susceptible. So anyway, when you see those little bars like that, that's indicating turbulence that I would be concerned with. I might still fly, but I'm going to warn my passengers it's going to be a multi-flight. And then they do have the flight levels there. So these again, like 240, they may know what that means. 24. Whenever you see an altitude or a number like below, like turbulence, it's always altitudes in hundreds. So this is 240, and then you multiply by 100, so you get 24,000 feet. So this obviously, for most light planes, they're not going to be at that altitude. So there may be turbulence below it, but at that they're forecasting moderate turbulence at that altitude there. Again, there's another one. So these are prog charts, I believe. So again, prognostic. Think of prognostic as somebody, forecasting. It's, you've heard the term prognosticators, people that are forecasting. So a prognostic chart is giving you an idea of what the weather is might do. But in this case, it's on a very large scale. It's looking across the whole U.S. So here we see a lot of the elements that we're talking about. There's our symbols for rain, thunderstorms right there. Let's see here. Actually, that's thunderstorm is really easy to understand that symbol. Just the lightning part there. High pressure. Here's a cold front. Here's a stationary front. Cool fronts. So weather runoff, things like that. So,
Joe.
Yeah.
What are them triangles?
This right here.
Yeah.
So that's I believe that's rain. I believe that's rain. I think this right here is snow. It's hard to tell. It's the snow is actually shows like little stars. So you'll see it's you can't really see it here. There's not much detail in it, but I'm pretty sure those are three stars. There's snow. That would make sense. It's up in this area right here. We've got cold front coming in from this direction right here. There, then obviously. Show here. There should be a chart that shows the different symbols here. Let's see. In the cockpit itself, you're going to see, there's several tools we can use. If you're flying a really nice aircraft, you've got a Garmin 1000. There's a nice big display. It's about the size. It's maybe a little bit smaller than that log there. But you can bring up weather, EDSB weather on the display itself, and it's just tremendously helpful. So if you're flying, here's a plane right here. You can see that there's some weather down here that's pretty strong return. There's probably a lot of rain in that area, I'm guessing. By looking at that, so that's something we avoid. But in this case, if they're flying up to Omaha, for instance, that's pretty clear up there, so they know that they're not going to be flying a lot of precipitation. Doesn't mean that there's no clouds there. It just means that there's no precipitation. And Yeah, they've got the next radar, which is what ADSB reports, to the cockpit. And you'd have, like on your smartphone, if you've got it with you, which you probably would. There's products like ForeFlight. There's some products that don't cost anything that you can get. ForeFlight is kind of expensive, but it's a very good product, very comprehensive, and it would have those charts, all that weather information on there. So it's back in the old days, in the 80s and 90s, we didn't have any of that stuff. We had weather before we took off, and then hope it didn't change drastically in the route. So here's some other images of this. I don't want to spend a lot of time on it, but this basically just is another tool that you can use to bring up information inside the cockpit. And again, you can use your smartphone if you got a tablet, an iPhone, or something like that, or iPad. You can use that to bring up other as well. Okay. Any questions on that? Right. Airport operations. So here. This is chapter 14. So there are essentially 3 types of airports. You're going to have civil airports, military or federal airports, and then private airports. We've got probably close to 20,000 in the U.S. All of those 20,000, and more than any other country in the world. The U.S. has just a remarkable airspace system, and the government has done a great job of promoting aviation. The government realizes, as do a lot of pilots, that airports are economic engines for the local communities. They draw in, they bring in, businesses. They allow businesses to travel from one location to the other without having to go down a major city, hop out a plane, and go to another. A lot of businesses use corporate aviation, corporate jet or plane or whatever, to get around, and it's super nice. I've told you guys before, I can hop in the twin actually at variable gear without going through any security, and I can be down in Florida in less than 6 hours. And if you're to do that, if I wanted to do that with airlines, I'd have to book a flight. I'd have to, go through their security, and I'd be lucky if I got there today. I mean, I probably would, but it would be today. Right now, I could plan out my flight and then hop on the plane and go down there. So there's an appeal to general aviation, aviation for businesses. So 2 primary types of airports that we will be flying into are going to be towered airports and non-towered. Can anybody guess what Reedsburg is? It's a non-tower. No. So there's no tower, no control tower here. So that means, as pilots, you'll hear pilots who fly here on a Unicom here, radio that is. They'll call in and they'll say, Reedsburg traffic, Cessna 264 Romeo is entering left downwind runway 36 or something. What they're doing is they're not talking to anyone specifically. They're just announcing, really a broadcast in the wild, just saying, if there's any aircraft in the area, I'm here at Reedsburg and coming in to land. And when you give all that information I just gave you here, which you'll learn here in a second, helps you kind of position where they're at or where you're at in all the airport itself. So whereas a towered airport, you're going to need a clearance. You're going to have to talk to. Now, towered airports don't always have full-time towers. La Crosse, Reedsburg, even Madison, they're kind of Class C airspace. They shut down at Madison is like 1 o'clock or something like that, and then it reverts back to just a regular airport at Reedsburg where they have to sell it out. So you'll hear, if you fly into Madison late at night or early, super early, 4-6, you might hear a jet coming in, a large jet coming in, just self-announcing. They'll just say, Madison, United flight such and such, inbound on final for 1.36 or something like that. And then a Cessna 152, they have to kind of coordinate between each other to make sure that they don't cause problems. They may talk, in flight. They may actually talk back and forth to make sure that they don't get away. So that's the big difference between towered airports and non-towered airports. And again, towered airports can shut down. They typically do at night. So there's nobody in the tower right like that. And then that towered airport then acts like a So you'll hear the term CTAF, that's the Common Traffic Advisory Frequency. Reedsburg's CTAF is 122.8. So if I'm flying into Reedsburg, I'm going to switch to my radios to 122.8, and then I'm going to announce to Reedsburg that we get to land. So typically you're going to make your announcement like 10 miles out. You're going to say, Reedsburg traffic, such that 264 Romeo was 10 miles southwest of the field at 3,000. So I'm giving my employee where I'm at and what I want to do. That's just a progression. And again, when you get into your flight training, you're going to learn these things, and it's going to be, well, for some of you anyway, if you're anything like me, it's going to be scary. You're talking to all these pilots that are out there that, they sound like, the pros and stuff like that. They all start in the same spot, by the way. They all, really terrified about talking on the radio. If you talk to pilots, a lot of them will say, "Oh yeah, that was tough learning radio." So, but the thing is, if as pilots, I love hearing that, because it means that somebody's learning to fly, and that's the way a lot of other pilots feel. They'll give you a break, if you're coming in. What they don't like is when you climb up and don't say anything. So if I were to fly into this airport and not say anything, not announce that I'm flying in and landing, that's not a good thing. So it's better to just think about what you're going to say before you say it, and then say it on the radio. And if you make mistakes, that's fine. One of the things you could do at tower airports, which is even scarier as a student pilot, is just let them know that you're a student pilot. You could say, Madison approach, Cessna 264 Romeo, 10 miles northwest, student pilot, landing Madison. And just to let them know that, give me a break here, and they'll work with you. Now, if they're super busy, what they may do is they may tell you can't enter their space, and that's more for safety reasons. They don't want to have any issues. They have their push time. There's like major airports have what's called push times. And push times are when all the airlines, have to get everybody up to all those destinations and stuff like that. They get really busy then. I've been down in Madison and I've seen 30 aircraft just all over the area in Madison. There's like a 30-mile radius, and there's aircraft everywhere. And they get really busy. They don't have time sometimes to work with students. If you go there on a Sunday morning, absolutely dead. They're twiddling their thumbs, and they really are looking for pilots to help, because they want to work with pilots. If you ever heard about, there's this thing called airborne surveillance radar, and they love doing that type of thing where they'll actually, what they'll do is they'll have you come in for a landing, and then you, with an instructor, they'll have you put your hood on or whatever, and then they'll give you specific instructions how to come in and land. They'll say, pitch down a little bit, bank to the left, stop bank, start bank, descend a little bit or whatever. They'll hand spoon feed you complete directions to get down. So if you're in the clouds and you need to get down, they'll talk to you all the way down, and they actually need to do that as part of the requirements. So anyway, all that to say is that Sunday mornings they're dead. Fridays they're super busy, so that's probably their busiest day, at least that I've seen. Saturdays can be busy, I guess, too. But so again, if you find out the days that they're busy, talk to your instructor, and say, what days aren't they so busy. Normally, when I take students down there, it's not as busy, especially the first time. Maybe later on we go and it's a little bit busier, just so you can hear what it's like for them to coordinate all this traffic, which is absolutely amazing. So, okay. Let's see. So different types of radios that they have there. This is, let's see, 14.1. So you're going to have Unicom. That's essentially a frequency. It's also, associated oftentimes with the CTAF, or Common Traffic Advisory Frequency. Common Traffic, again, advisory frequency is going to be for airports like Reedsburg, not Madison. Madison has a tower frequency. But a CTAF is Common Traffic Advisory. And it's just that. You break that term down, common traffic. That's common traffic for all the common traffic in the area there. So again, Reedsburg is 122.8. That's a typical frequency for that. Bearwoos is a little more discrete, you have a different one, but in any case, here, you'll see that, and then that's what you're going to talk to when you're coming into the airport. Seems like a really simple thing, but a lot of times pilots will come in and they'll forget to change the frequency to the airport they're landing at, and they'll be talking like they're announcing to everybody at the airport they're coming into, but nobody's hearing them, and that is a dangerous thing. Because you can, the vast majority of mid-airs occur close to an airport, and that's because somebody didn't hear, or somebody didn't, get the word out that they were coming into land and have an incident or something like that. So it's always a good idea to check your frequency, and you'll know if you tune in like 20 miles out, 15, 20 miles out, you'll hear other traffic typically talk. If it's a dead airport, then you may not hear much of anything, but a lot of times on a day like today, you're going to hear a lot of traffic get up in the air. It's talking. So Unicom actually has to do with the facility that's running it. So Unicom is I'm not sure what that means. It's a frequency that oftentimes a business on the field will monitor. So if you want to get fuel, for instance, you'll call the Unicom frequency. Most of the time, the Unicom frequency is the same as the CTAF, the Common Traffic Advisory frequency. And then multicom, that's always the same frequency, 122.9. Again, you're going to announce, do self-analysis when you're at if you're taking off from Winsburg here, you start the plane, you'll make the announcement to Winsburg traffic. Taxiing at 118 for the south call. And that lets out anybody that's coming in know that somebody's going to either be in the taxiway or they're going to be leaving the airport shortly. So it's always a good idea to kind of announce what your intentions are as you go along there. These are pretty much all the same here. So again, you're airport. Like, again, most of the time, most of the airports you're going to fly into are going to have a CTAF frequency, the Common Traffic Advisory frequency, or multicom. It doesn't make a difference. It's still, if they're all frequency they talk. There's no difference between them. Just as we described. Unicom is going to be typically associated with business. At a small airport where there's no business at all, you don't have any fuel services or anything like that. It's just going to be the CTAF. So, right. Pattern entries. So when you come into land at an airport or take off for that matter, you're going to follow a pattern in getting into the airport. So the typical aircraft pattern. So here's our runway right here. Right. If we're down here, let's say we're coming into land here, so there's our plane. Let's say this is runway 18 right here. The runway numbers are always painted on the runways there. And then this, does anybody know what runway this would be if that's going to be? 36, right? So that's the runways are always showing the magnetic direction. So in this case, this direction right here is north, and then this direction right here is south. Okay, and because the runway here is oriented north and south, we put in 180. 180 would be south, right? 360 is north. That's our north is that direction there. So they put the numbers on there so you know which runway that you're landing at. So in any case, first off, the first thing I do if I was like 20 miles out, they're going to have, there's usually like a little radar, like an AWOS or something like that. AWOS stands for Automated Weather Observation Service. But I tune to that frequency and listen to what the winds are doing. Let's say the winds are, let's say they're out of the south. So our winds are like this, and let's say they're 20 knots, like wind there. So that's our wind mark there. One of the things I'm going to need to know before I get to the airport is what is our pattern altitude. The pattern altitude is what the altitude that we're going to fly around the airport to come in and land. We don't just fly in and just come in and land here. We obviously want to land into the wind. We don't just come in and land. There's a very specific pattern that we're going to follow. And there's different legs of the pattern. So first thing I'm going to do, listen to AWAS, get the winds. Okay, I've determined now that the winds are out of the southwest. I want to land on runway 18 because that'll keep the winds there. It'll keep me landing at a slower speed. I don't want to land with the wind because you're going to cover a lot of ground really fast. If you've got 20 knots, you can add it onto your landing speed. So if you land at 60 knots, let's say, you're now traveling along this runway at 80 knots. So we don't want to do that. I would much rather land at 40 knots. I mean, my landing speed may be 60 knots because I've got a headwind. It's slowing the aircraft down as it's moving forward. It's not going fast. Whereas if you got this, the plane is, you got wind blowing behind you and it's pushing it down fast. That's when we land. So what I'm going to do here is I'm going to enter what's called the left downwind on a 45-degree angle right here. So this is our 45-degree angle. There's our plane. We typically want to be within 1 mile to 2 miles right here. So this is 1 to 2 miles, depending on the size of your aircraft, how fast you move, things like that. So typically it's about 1 mile from here. On a Cessna, it's really easy to determine. What you do is you just as you're flying, what you do is you look out. There's most Cessnas have that spar that support that holds up the wing. It's the distance that you want to be at. When you're 1,000 feet above ground, you're gonna put the runway about halfway through that spar. You're just going to keep it there. That's an easy way to do it. Over time, you'll know, what basically what it looks like if it's right or not. Now, of course, you can use your altimeter, but if you can look outside, especially at an airport when you're coming into land, it's safer because you have to scan for other traffic at every point, especially when you get close to airports. Okay, so we get down to 1,000 feet above the runway. Against 1,000 feet above the runway is standard for most airports. There might be some, changes at some airports, but the vast majority of it is going to be 1,000 feet. That's our pattern altitude. So here, the elevation at Reedsburg is 920 feet, I think, something like that. Does anybody know what the pattern altitude would be here then? 1,000. Yeah. And so they usually round it up or down. In this case, it's 2,000 feet. So they give you a little bit of cushion there. So we come in. We fly our left downwind right here. We make our announcement right here. When you turn the aircraft, that's when you make your announcement. The reason why you want to make your announcements when you're turning the aircraft is because the aircraft becomes more visible. Like when I hold the aircraft like this, you can't really see it. I mean, you can see it, yes, but when I turn it like this, now you got the wings that are displaying. And as you're doing your turn, people can see that a lot easier, especially from a distance away. So you always, if you can anyway, make your announcements when you're doing your turn. And again, that gives you more visibility. That way, if I'm out flying and I see you out flying, I hear the announcement, I'm going to be looking for that aircraft. I'll be able to see those wings, as they go into the turn there. So we'll make our announcement right here. The announcement goes something like this, and you don't have to go through the test. You're going to have to know it, obviously, for a practical test. When you actually go up, you're making radio calls. But you'll say, reasonable traffic, Cessna 264 Romeo, entering left downwind 45 for runway 18 Reedsburg. So again, here we're telling them where we're at. Everybody knows pattern altitude at Reedsburg is 1,000 feet, so they know that they're at 2,000 MSL above sea level. And so they'll know roughly where to look. They know that the left downwind starts over here at the start of runway 36 there. So that's where they're going to try to look for you. And then here we'll just fly this downwind, and what happens here, again, this is called the downwind flag right here. And the reason why it's called downwind is because our winds, I'll just repeat this symbol up here. The winds are out of the northwest. We're going down with the wind. We're traveling with it. And as opposed to upwind, if a plane was traveling this way right here, let's say, this would be going up against the wind. Okay, that's the term. So this is the downwind leg right here. All right, what you're going to do is you're going to come in and about 45 degrees out from your touchdown area or at the end of the runway there, you're going to do a turn to left base. That's what this is called. This is called, you can call it base, but I like calling it left base because it's to your left. As I'm flying right here, I'm looking out, my left side is right here. And the reason they do that is because most pilots fly their planes with the pilot on the left seat there. Okay, so when you're sitting there, it's easier for me to see that that runway there from the left seat. So that's why they fly the left base there, or the left downwind and left hand pattern. This is a left hand pattern right here. So I'll show you what a right hand pattern is. You can actually figure it out too, just by looking at it. So again, this is the base right here. Base. In this case, it's a left base. Because we're a left hand pattern. And then here we do a turn to final. We make a radio call right here. We do a turn again where I'm looking out when I'm flying the aircraft. I'm looking behind me like this. And I look for that 45-degree point where it looks roughly about 45 degrees. And then I'm going to do my turn to left base. I'm going to make my radio call. It's very traffic. Cessna 264 Romeo enter left base runway 18 Reedsburg, full stop. So what I've said there is who I am, where I'm at, Reedsburg traffic 264 Romeo, left base. You're telling them where you're turning left base right there. So you're going to be looking for those wings there, and then you're then telling them what you're going to do. Landing runway 18, full stop. Full stop indicates that you're coming. You're going to actually stop and then exit the runway. You're actually staying on, as opposed to a touch and go. You could say Reedsburg traffic, 264 Romeo and left base for touch and go on way 48 Reedsburg. And that's going to let them know that, if they're, let's say they're taking off from here, they're going to expect you to maybe get down on the ground here and then do power up and actually do a takeoff. And maybe you're doing just circuits or just practicing your landings or something like that. So again, all that communication you're putting into a small phrase there, but you're very concise with it. It's communicating everything to anybody out there that wants to listen, and it's warning them that you're coming into land. So be aware of that. So coming into final Reedsburg traffic 264 Romeo, entering final 118 Reedsburg, full stop. They come here, they land, and then you taxi off. Typically, you come in and land on a runway you want to clear it as soon as you possibly can. So you just basically taxi off, and as soon as you get done, go to the vehicle taxiway. So, and at that point, you'll probably make an announcement as well. Reedsburg traffic 264 Romeo is clear of the active or 180. It's probably best to use the runway that you've come in on to say it. So you'd say Reedsburg traffic 264 Romeo is clear of 118. Anytime you cross a runway, so Reedsburg actually has another runway. It's a very short one, this right here. So here's the taxiway over here. When the plane is taxiing, you're going to make announcements that you're crossing the runway. Anytime you cross a runway, you have to let people know, because there could be somebody coming in to land here, and they may not see you for whatever reason. So you just say, Reedsburg traffic 264 or come crossing runway 07. So yes, that's consistent. Very well. So, but in any case, so you have taxiways, and this is a common problem with traffic that's coming in, where you've got airports that have multiple runways. So you want to let people know where you're at. Again, the whole idea here is to be safe. Make those announcements and make sure that people know where you're at and what you're up to. So in the diagram here, they've got the plane crossing over the center of the runway and then in the left downwind. So that's a common tactic. So this pattern right here works great if the plane is coming from this east side right here. But if they're coming from the west, what they'll do is they'll overfly the airport at 2,000 feet MSL, and they'll enter midfield left downwind. So the call there would be Reedsburg traffic 264 Romeo entering midfield left downwind, runway 18 Reedsburg. They may make their call right here, and they'll say Reedsburg traffic over the field at 2,000 left cross for runway 18. So let's take a look at the thing. So this is downwind right here. Oops, downwind right here. Base right there, final leg. Okay, and then can anybody tell me what this leg might be here? This one going this way. So we know we've got downwind And what's the opposite of down? Upwind. Upwind. Okay. So you've got down and up. This would be upwind. Again, you're heading up the wind. You're heading into the wind. So that's the this is the upwind right here. And then this right here is called, just mentioned it. What's that? No. Now, if we're coming in here, this is the base there. Well, that would be true if we were coming in from this angle right here. That would be true. But actually, if we're flying these patterns right here, the left downwind, the winds are out of here, this is called the crosswind. Okay. So again, base on this side, crosswind here, downwind, upwind. Okay. Those are the different parts of the pattern there. Normally when we land, you know, we don't talk about upwind, but if we do a go around, then we want to tell people that we're in an upwind. You know, we're somewhere along that line right there. And then crosswind just tells us that we're over here. And again, it depends on the winds. You know, if we're flying, let's say the winds were out of the northwest instead, then this would be considered a right-hand pattern. So let's actually do that. This just changes around. So let's just say the winds are out of the north here. So now this becomes, let's say our plane is over, well, let's make a difference. Let's say our plane's right here. We're coming in. What we're going to do is we're going to enter in a right downwind for runway 36. Okay. So here plane enters right downwind. And the reason why that's right is because if I'm flying my plane right here along this side, I'm looking out the plane. I'm on the left side of the plane right here, right? So as I fly over here, I don't know if you guys can see that there, but as I'm flying like this, I'm in this side of the plane right here. I'm looking out the right side of the aircraft at the runway there. So it's called a right pattern here. So again, everything's the same. It's right downwind and then right turn to right base right here, and then final. We don't say right or left final because there's only one final, and the same with upwind. It's just upwind there. So, all right, does that kind of make sense? Kind of. What don't you get?
It's just something I have to do.
Yeah. What you could do is look at those diagrams there. The thing here is, you know, it really depends on where you're coming from, where you're landing. First off, you need to determine, you know, what are the winds for the airport? What's the best runway to reduce the amount of touchdown speed that I am coming into the runway? We've done that, like here in this case. Well, I should probably erase. Let me just grab this here. So again, the whole idea here is it really, you have to determine, you know, where you're going to be landing at. You know, if you got a runway here, let's see, like this here. If the wind again is out of the north, I'm going to be landing. I want to use this runway right here. And it doesn't make a difference where the aircraft is, over here, over here, over here, over here. We want to get to, in this case, we want to get to this point right here to start our left downwind right here. This is the left downwind. Again, I put myself in the cockpit right here and extend my left arm. The runway is going to be here. So it's the plane right here. Just there. And then that's me on the left-hand side. So I'm looking out at the runway as I'm flying there. So this now is the left downwind form, in this case, runway 36 here. So that's how I make that determination there. So, and again, same pattern altitude, 1,000 feet right there on the entry. And then at some point, depending on the aircraft manufacturer, the POH, they may have you start, you know, driving this, you know, descending at this point. It could be out here a little bit further or whatever, or maybe over this way here. So, but the whole idea here is to you know, have an orderly fashion for entering in an airport. Now, when you go to a towered airport, they may, you know, it's like, okay, so this is a non-tower, typically a non-towered airport. you have to do the full pattern. Again, the whole idea here is to keep aircraft safe from each other. At a tower airport, they may say enter 2 mile left base, or do a straight in for runway 36 or something like that. So they, because there's somebody watching you from a tower cab, they've got binoculars, they're looking out, or maybe they've got their radar, they even have ADS-B. You'll actually, they can actually direct you to a specific point. They'll say enter left downwind for runway, whatever. But maybe if you're coming from this direction over here, they'll say we'll enter a left base for that. They want to expedite the flow of traffic. That's their, and do it safely. So what they're doing there is, in this case, this is our downwind right here. This is our base right here, and here's our final right here. So if I'm coming in from this direction right here, they may just say, okay, well, do a long final. So I would fly over here and then do my final right there. Or they'll typically, what they would do is they recommend that they tell you to do a left base, like a 2 mile left base. So maybe out here they want you to enter it in, and they'll launch you out there as you come in to land there. So that's what you're typically going to see for patterns, entering in patterns. This is a crosswind right here, midfield crosswind actually over the runway. So and the whole idea behind this again is to prevent mid-air collisions. What they learned early on, it was just not a good idea to let anybody come in and land without some sort of organization. Each one of these turns right here is a reporting point that you're telling somebody out there that I'm there. Now there are what we call NORDOs, which are no radio aircraft, hypercog or something like that. They don't have any radios, so it's still incumbent on you to be looking outside the aircraft. You don't want to be buried in avionics, looking at avionics and stuff like that. You need to be, you've heard it before, keeping your head on a swivel. The fighter pilots, they talk about that, keep your head on a swivel. It's the same thing when you get close to an airport like Greensburg, Baraboo, smaller airports. There's still a lot of traffic that can fly in there, and you need to be on the lookout and listening for other traffic. Another consideration too, when you're coming in for landing, make sure you've got the volume turned up on your radio. If you've got passengers, you obviously want to make sure that they're aware that you need to be listening to the radio. I always tell my passengers, if you see my hand up, that means I'm in silence because I'm listening for somebody else that can be coming into the airport to land there. And maybe they're trying to talk, but I'm not able to hear more of their conversation. So those are things that you'll work out. So this is a chart supplement document right here. The chart supplements essentially give you additional information about all the different airports that you can land at. So there's a chart supplement for Wisconsin. You can go in there and you can look at all the details. There's a ton of stuff in here. I won't go into all the details. One thing I can give you a hint on the test, in the supplement they give you, the testing supplement, there is a detail of a chart supplement page in there. So use that if you have questions. If they talk about, well, what does this mean here? Look through that chart supplement. You'll actually see they have a legend for it that actually describes everything. The answers are right there. You just have to be able to look for them. And again, that's in the testing supplement when you take the FAA exam itself. So here, this is really well written out here. The name of the airport here, and then their ICAO identifier, where they're located in relation to the city, 4 miles northeast. The time difference between your universal coordinated time is 6 hours, or minus 6 hours of UTC. So if it's 12 o'clock locally, for instance, UTC maybe 1800 Zulu. In this case, or vice versa. If it says it's 1800 Zulu, if the time is 1800 Zulu, it's going to be 12. It's during daylight savings time, it's going to be 5 hours. Your latitude and longitude from the airport, and then there's some various other things here. Like I said, I don't want to go into details on this because there's so much information in here. You do want to go through here. There's a communication section that describes the different frequencies here, the ATIS frequency for this airport. Now, this is a tower airport, so they actually have several different frequencies here. They've got the tower frequencies right here, approach control. So they actually have an approach, would be Birmingham approach. And then they do have a Unicom frequency. This is their ATIS frequency. ATIS, does anybody know what ATIS stands for? ATIS stands for Automated Terminal Information Service. And that's like AWAS. It's very similar to AWAS. AWAS, Automated Weather Observation Service. ATIS is Automated Terminal Information Service. That's actually spoken by a real person typically. And they're going to go ahead and they're going to do a forecast for the next hour for the airport, given the aircraft or the conditions for the airport. They're also going to tell you if there are, any like construction issues, taxi problems, or anything like that, or traffic flow things. They'll announce that in that ATIS. And they usually they usually identify ATIS with like a letter of some sort. So they'll say ATIS information Mike or something like that, or Oscar or something like that. And that just tells you when it was issued there. And they'll have the issue, the time that it was issued there. So again, that's ATIS automated. That's on page 14-5. Let's see. So let's get into runways, airport markings and signs. Yeah, what I would do is definitely start looking at some of these documents. I think in your Zero Echo website, the SIA Zero Echo website, I've got several of these on there. You can look up. You can download entire, chart supplements from the FAA website as well. I think I've got that link on there as well. So let's look at the airport signs. So airports can get really common. Especially larger airports. Reedsburg, not so much, because you've got, just one runway. There's one major taxiway that goes here and it winds up down here at the terminal right here. And then this is the big ramp area. But Madison, for instance, that can be kind of scary if you've never been to a large tower airport. So, but the one thing that they both have in common is they use the same types of signage. And you'll see this actually pretty much anywhere in the world when you fly to an airport, international airport, they all use the same types of signs. So let's get into that, what the different types of signs you're going to see. So some signs are actually painted on the surface of the taxiways or runways. This right here is a relocated runway threshold. So it's not displaced, it's actually relocated. This and you can tell that this right here is a taxiway, especially back in the sign in here. So these yellow lines always indicate that you're on a taxiway. White means that you're on a runway. So when you see white, you're on an active, you're on a runway. Yellow is always going to denote taxiways of some sort. So this right here, that's a runway right there. This right here is a runway. And here's our relocated runway threshold right here, marking. And there are two types of, let's see that. So a relocated runway right here, or a threshold right here, is just saying that you can take off from this area right here. You cannot take off or start your takeoff run here or land in this area right here. And it makes sense when you look at that. You've got these taxiways here. There could be planes taxiing around. They could be a plane landing right here. So they don't want any planes taking off here. You can take off from here and and land on this area right here. That's totally fine. But they just don't want planes taking off or landing on this portion right here. And again, that's called a relocated, which is different than a displaced threshold. So, and I'll show you that in a second here. So let's go here. All right, so this is a displaced threshold. And notice the difference. This is a relocated threshold. Notice it's just a solid line right here, and you've got these arrows. A displaced threshold is they actually move the threshold of the runway right here. This is the runway right there. This direction right here the difference being is that you can actually use this displacement threshold to take off. So if I taxi out here, Reedsburg has got this right here on runway 18. If you taxi out right here, we could walk out there and you'd actually see these lines in the pavement, these arrows. That means you can actually taxi out here and do your run up and take off from here. You just can't land on that. Now, why would that be? You may know why that might be. Why do we have it displaced like this? Think about Reedsburg. Okay, we've got this busy road right here. Okay, and the runway is like right here. It's right there. So we've got Highway 33 that's right here at Reedsburg, and then here's the runway. Why would they displace this? Yeah, that would be one way of doing it. Yeah. Yeah. It's for safety. They don't want planes coming in too low. Long time ago, even I think before I was born, there was a plane that came in really low. I think it actually wound up hitting. Back then, there were just like a bunch of car garages and gas stations right here. It came in so low it actually hit one of the gas stations. So the FAA said, listen, we got to make this safer, so let's displace this threshold, and then we're going to force planes to land further down the runway. So that means that they're, instead of coming in lower, like right here and landing, you're now going to have to aim for a point, out here, further down the runway, so that they don't come in really low. That's the displaced threshold. Again, the distinction between a displaced and the other threshold, relocated threshold, is that on a relocated, you can't take off and you can't land on it. A displaced, you can take off on it, but you can't land on it. And you just think about the purpose of it, okay? Displaced, and think about Reedsburg, got a displaced threshold here. Why do they have it? Because the busy road, they've got buildings over there, they don't want you slamming into also, right? And that's in the pavement. You'll actually see these lines in the pavement. This right here is the threshold right here. Touchdown zone markings right there. Okay, and again, taxiways are yellow, runways are white. So the other types of things you're going to see are signs, airport location signs. So this is a typical sign that you'll see. Whenever you see a sign that's in black with a yellow letter, that is a taxiway sign. So that's telling you you're on taxiway Alpha. This right here is taxiway Bravo. The red, anytime you see red, it should be a warning to you. Again, the FAA is very specific in how they use colors, things like that. Red indicates that you're about to enter a runway. Okay, so in this case, we can see here, if I'm right here at this threshold sign right here, when I taxi out, I'm going to be taxiing out onto runway 9, like that direction. Okay, if I'm right here at Bravo, for instance, and B for Bravo, I'm going to be taxiing out onto runway 27. Okay. Another thing we'll get into here. Yeah. So let's take a look at what it looks like in real life. This is a taxiway sign right here. Now, this marking right here is a threshold sign. What we're not seeing behind us right here is the runway. It's like right here and somewhere in this area, but we're only seeing the taxiway sign. So again, taxiways are always denoted with a letter. They're in black with yellow lettering. Okay, and you'll see them. Whatever taxiway you're on, if you see a black sign with a yellow letter in it, that's the sign. Now, one thing to help you. Runways are always numbered, right? Taxiways are always letters. They'll always start out with a letter. You may have K or kilo. The ATC will always refer to it in their phonetic pronunciation, say kilo or something like that. So in this case, this is taxiway kilo. That's this stretch of pavement here. The other thing that you're looking at here and you need to understand is this threshold marking sign. So in the standard threshold marking sign is 2 solid lines and then dashed lines. What this means is air traffic on this side is on the safe side of the threshold. In other words, they're not on the runway. On this side right here, we're not on the runway. On this side, the dashed line, you're entering into the runway area. Okay, so if you land in an airport, you want to get on this side of that double solid line. You don't want to be there. And I always got confused with it. can never remember which side was safe. You know, and obviously when you're out there flying, most of the time you're going to know. But at some busy airports, you may have several of these lines really close together, and it may get kind of confusing. So what you want to do is just remember that these dashes, the double dashes right there, that's what you're going to see out on the runway. We've got dashed lines in the runway. The solid line is a straight line. You're once you cross that, then you're safe, and no one's going to land on you or anything like that. And on top of that, ATC expects you to cross that line completely. Tail the aircraft has to cross that line for it to be safe. Otherwise, it's considered a runway incursion. You know, if your plane is, your tail's hanging over this and the plane takes off over it, that could be considered a runway incursion. And they get in hot water, then something like that happens. It's their responsibility to help, you know, keep traffic safe, keep them separated safely. And it's also up to the pilot and command to make sure that they do it safely as well. So, okay, let's see here. Okay, so this is again the threshold sign right there with the taxiway sign on it. Here's another one right here. So we're on taxiway Alpha here, and we're about to taxi onto runway 14. So when you see that, it's you'll know kind of where you're at. So at this point, if ATC said, well, "Where are you at?" I'd say I'm on Alpha at runway 14, and they would know exactly where to look there if there's an issue there. You also will now know where you're at. On charts, you can actually see where you're at there. Here's another example that you're on taxiway Alpha, and to your left is runway 18 or 18, and to your right, if you do a right turn, you're going to be on heading down runway 36 there. So, and again, red should be, you know, give you an idea that you got to be really careful you're entering a runway there. Anytime you see red, yellow, you're on a taxiway. Right, and on charts, oftentimes like in the taxiway diagrams, they have a bunch of different symbols on there. They'll show like the buildings and stuff like that here. So one of the things that initiative they started years back was you know, trying to help pilots avoid some of the hot spots. So before you take off, you would preview, you know, what taxiway you're going to use to get to your runway. So if we're in this case, for this is runway 17 right here, we taxi on Charlie right here. That's C. You can see there the C there, and then onto runway 17 here. But if you were going down this way, this right here is a common hotspot for this airport, and you can see why. You've got a junction of, you know, a taxiway and two runways. So they've known in the past that at junctions like this, that's where accidents occur. You know, minor incidents, where, you know, planes can, you know, clip wings or something like that. So they always identify it in there, and that's they're going to have these HS. In this case, it's HS1. We've got the other ones there. And that's the one I see in this type here. But that's an area that you need to be extra vigilant in when you're taxiing. You should always be vigilant when you're taxiing out. So you see here's the taxiway letter Alpha, Golf, and then obviously our runways here. There's Delta. That right there is Delta. This is Echo right here. So you just by looking at this, you can kind of get an idea. You know, they would, you know, if you were at the terminal building, let's say, they may say take Charlie to, you know, Echo, and you know, do a midfield takeoff. Or they may say, you know, taxi to Charlie Alpha to runway 31. Now, one of the things that ATC will also do is they'll also tell you to hold short of runways. Yep.
There's also a hotspot too.
Oh yeah, where is that? I didn't see that. Oh yes, right there. Okay, I did see it. So yeah, I saw that. So this apparently there could be a lot of traffic here. Maybe there's, you know, they got a fire station here. Maybe there's something else. It could be. It doesn't make sense that it would be a hotspot, but it could be because there's a lot of ground traffic through there. And my guess is in this area right here, that's the Air National Guard ramp right there. They're probably going to be taxiing their aircraft along this taxi right here. So they're probably designated that as a hotspot as well on there. And again, it's just a solid, circle or ellipse, around the area there. But it could be, again, I'm guessing because, if these planes have to get to this side of the airport, they have to use that taxi. They're not going to taxi down. They're going to use the taxiway here. So they designate this area as a hotspot. Zip. All right, in pavement markings, again, here's, you've got, this is runway 32 right on the left-hand side and runway 14 left on this side. So if I go out here, notice there are threshold markings. So now when I cross this marking right here, notice the dashed lines right there that go across, we're entering in a runway. You kind of make out just a little white paint out there. That's the runway. So if I turn down this way, I'm heading down to the approach end of runway 14 left. So I go down there and I see on the pavement as I do my right turn here, I see the numbers 14 left upside down because and then I turn around and take off. Runway 32 right. If I do the left turn here, I travel down the runway again. If they wanted you to do like back taxi, which means taxiing back along the runway there, you would go down here and you'd see the numbers 32 are on the runway. That's the approach. 32 right. Okay. So you'll see the signs like this, but you also see the inside in pavement markings as well. So they do everything to make it easier. It still is, at a airport you've never flown into, a busy one in particular. It can be challenging for pilots. Again, this is the taxi side. This is the active or the runway side there. Again, the dash is there on that side right there. The taxi lines extend out onto the runway where you can turn onto the runway itself. So that works both ways. When the plane's coming off, they'll follow that yellow taxi line, taxi past this threshold here. Yeah, the taxi direction there. We can see this is in this case we're just landing on this side is where the runway is right here. We cross the threshold and we're going to taxi along that yellow line to FDO or so. Yeah. Okay. These are runway distance remaining signs, and you'll see them on runways. They are going to indicate the number in thousands of feet left. So if I see this, marker, this black sign with the white 2 in it, I know I've got 2,000 feet of runway left. And you'll see that smaller airports, but you'll always see that larger airports. They've got the runway distance remaining. So, and they'll have that, you'll look out, it's typically going to be larger fields. And, this is a very complex, you'll see this like down in Chicago, there's a lot of stuff going on here. All right, so let's break it down. So here's a taxiway. We know it's a taxiway because it's got a yellow sign in it. Typically, taxiways are also going to have yellow markings along the sides here. They don't show up here, but most of them are going to have that. So I can, they can direct me to taxi to 35 left, in which case I would taxi along here, and I would stop right here before I cross that threshold clearance to take off 1.35 left here. And then I would continue on, take off here. However, because of the way this airport's laid out, there might be another, like if it's down Chicago, they've got like 4 runways that are all parallel. They may have one taxiway that passes the threshold of all of them. So what they, and here what they want you to do is to taxi on these other sides. They want you to avoid this area right here. It's the racetrack, and they want traffic to stay out of that area. That's the dash lines there. Then obviously we're restricted by our threshold markers here. So if I'm in here, I'm safe, somewhere on this side here or here, I'm safe from approaching traffic and things like that. So over here, if I'm taxiing across these runways, here I would, get clearance. Anytime you cross a runway at a tower airport, you absolutely have to have a clearance. You can't just cross a runway. You'll get into big trouble, and it's very unsafe. So, and the ATC is going to give you, they'll say, you know, cleared, hold short of runway 35 left. Cleared to, they'll say, you know, they'll give you clearance. They'll say, you know, clear to cross runway 35 left, continue on, hold short of runway whatever to this text. And they will never clear you all the way across the airport. They'll never say this, okay, cleared to runway, you know, 34 left or something like that. And where you cross several runways, they'll only clear you to the next runway. So you'll know if you're confused at all, you always ask. Say, you know, Madison Tower, am I clear to, you know, cross runway 36? And they'll have to tell you if they're clear to cross all. That's again to avoid, you know, confusion and also congestion and you know, accidents. All right. So again, that's an example of a real complex diagram there. These little red marks right here, those would be, they'd actually have the runway number on it. So in this case, it could say 35 left right here, right here. This would say 35 center because you're going in that direction. So it'd say 35 center. Okay. Again, here is, again, our taxiway is right here. This might be, this threshold. You can see the white lines there. So my guess is on this side is the taxiway side here. But again, runway is going to be on this side right here. And you can see here you're entering 3517. 35 to the left. Here's another sign. What taxiway are we on here? Yeah, Delta. We're on Delta. Okay. What's that D sign? Right. If you take it left or right, Bravo is going to be perpendicular to us. You guys want to take a quick break? You want to keep at it? Do we want to take a quick break at all? Sure. Okay, break. All right. Let's break for like 5 minutes and then we'll dive back into it. We can get this out of the way then. We could, yeah, we should do this for the next. All right. Let's get right back into it. All right, so Black again is going to indicate, the actual taxiway that you're on. And then yellow, inverted yellow here, Bravo, that's going to be your next taxiway that's coming up. In this case, this taxiway is, crossing in front of us here. So if we take a left, it's going to be Bravo to that direction, Bravo to the right. Oftentimes they will have, again, pavement markings. Again, yellow markings indicates taxiway. Bravo is in this direction right here. Alpha is over off here. You can see all the pavement goes off in that direction. Very complex layout here. You've got all these taxiways right here. This is probably a hotspot. So this is the kind of sign you're going to see at this intersection right here on Bravo. You're on Bravo right there. Okay, black sign, the letter B indicates that we're actually on this taxiway right here. This is the sign that you'd see if you looked out the window in the grass there. It's going to have a sign like this standing up, facing you. And it's going to have Sierra off to the, if you did a 90-degree left turn, that you're going to be turning on the Sierra. If you do like a 135-degree turn, you're going to be off on Foxtrot. And then obviously, right 90-degree turn on the Sierra. And then a sharp right would be Foxtrot. So there's Foxtrot right there. What would I see if I was like right here? What sign would I see here?
You can see that black F.
Black F, yep.
You'd see a.
If I'm going in this direction right here, what might I see? It's like Sierra. No, if I'm actually going this, I won't see the Sierra sign. I'm actually going in this direction right here, going toward the. What's that? Yeah, you'd see a red runway number. Yeah, you'd have to, there'd be a threshold. They don't show it here, but there'd actually be a threshold marking right here telling you, you're about to cross. Actually, yes, they've got this marked here. Yeah, this right here would be, you'd see Foxtrot because you're on Foxtrot right there. You would stop here though before you cross that to get clearance to take on. And same here. If I'm right here, we'd probably see a Sierra or S market right here. Good. Enhanced setting. This is something that's relatively new. So when normally a taxiway is going to look like this, but when you see something like this, that means you're approaching a runway, a whole position marking there. So it's just giving you a warning saying a runway is coming up. So if you happen to see this as you're taxiing, that means you're approaching a runway. And here they say it's like 100 feet out, 150 feet out. So it's just giving you a warning. You got to be ready to stop. Okay. These are destination signs. FBO stands for fixed base operator. It's what this building is. There's a fixed base operator here that just runs. They handle gas. They sell food and things like that. That's called a fixed base operator. That means they're fixed base. They're based at the airport. They're fixed on the airport, and they're operating. So in this case, it's just saying that FBO is in this direction. Just keep going straight. And eventually, this sign to turn the FBO. That's typically where you would expect to go to fuel up the tanks or something like that. Again, here's these are runway destination signs right here. Again, here's the taxiway that you're on. Taxiway destination right here. It means it's crossing in front of you. So this right here is probably taxiway number right here in front of us. But these are runway destination signs. If I want to get to runway 20, I'm going to do a left turn here to get to the departure point of runway 20. Runways 3, 2, and 14 are off to my right. So right, I can get down to those departure points there. Again, very anytime you see something in yellow, it's usually informational. Where again, red is really critical. You need to pay attention to it. Here's a good example of a red sign. Does anybody know what ILS stands for? Well, you can see it right there, I guess. It stands for Instrument Landing System. We know we're on Gulf right here on the pavement. we know that we're on one or a taxiway Gulf. This ILS sign, what this is for is, here we go. Yeah. So ILS stands for Instrument Landing System. And what it is, it's a beam of radio waves that is projected from the ends of runways so that pilots can come in, they can follow that beam all the way down to the runway and land. Why do you need to do that? Obviously, if it's really cloudy, it's really foggy or whatever, they need that instrument landing system so they can follow that beam down to touch down safely. The problem is those are radio waves, and airplanes are made of metal. And when you taxi a plane in front of the antennas, like this right here is this right here, the antenna right there. If you taxi a plane right here in front of that antenna, a plane that's receiving that signal may not now get the right signal because it's reflecting off your plane. So what they do is they put in these ILS hold short or ILS thresholds right here to have planes stop before they cross into that area where a plane, this guy right here is landing right here on this runway, and he's on the glide slope. And if this guy was out here like right here, this plane is here, it may have twisted that signal around so that this guy thinks he's now on the right flight path and he actually isn't. So they do this because obviously you don't want planes getting those incorrect radio signals. They're normally they're not always active. These hold short guidelines, hold short sign or threshold there. Usually they're at bigger airports because bigger airports have ILS systems. They're more expensive. You don't see them typically at an airport like Greensburg or Baraboo. Baraboo does have a localizer approach, but at Madison, there's several of these down there because they, big planes rely on the signals to get in, and so they'll have you hold short of the ILS, hold short lines there. So this guy here is taxiing out. They'll give you specific instruction to hold short of the ILS threshold there. Even though the actual runway threshold is over here, if this guy wants to take off, here this pilot would come around here, they taxi up and hold short here. Under normal circumstances, if it was VFR conditions, and then they take off. But in this case, because the weather is bad, they're going to stay short right there. Make sense? Okay. Yep. Again, you've got this is a taxiway hold short line right there, just a black marking with yellow dashes in it. At really busy airports, typically, obviously, it's going to be like Chicago, obviously Milwaukee, Madison, may have something like this right here. But that they may have you hold short of that line, so we'll say hold short of Bravo at Gulf. So you taxi up to this, and that's because you may have like larger aircraft taxi in front of you or something like that. So it's a runway hold short lines. They're taxiway hold short lines. X is, you can probably guess it means don't land here. You'll see X's on runways when they're doing construction on it, or if they're tearing it apart. And it can be anything. It can be a tarp laid out in the form of an X. It doesn't have to be any particular sign, and it doesn't even have to be lighted. But to close a runway, what they'll do is they'll typically put some sort of, like in this case, this is a tarp. It's just like a yellow X on the runway. That means you can't land there. Very simple. If you see a lighted X, don't land on there. And that's usually because either the runway's unsafe, they're doing construction on or something. Yes. Airport beacons. So airport beacons, there's two different types of beacons. You're going to have a white and green, alternating green. So that's what we see at Reedsburg here, Baraboo, Sauk, Boston. They all have these beacons, and you'll see them. They rotate, I think, every 3 seconds. They'll rotate around, and you'll see that flash of white or green. 5 seconds, you'll see one or white or green light there, and that just is very useful for pilots looking for an airport at night. I can see the Baraboo beacon easily from Madison. at night. If you're at 5,000 feet, easily you can make out there on a clear night. And in some cases, I've seen it as far away as, gosh, a little outside of a foot across. And again, that is, the visibility has to be really good. So these beacons are really strong. Reedsburg doesn't have quite as strong a beacon, but it's still very visible from like 5-6 miles away. You can easily make out Reedsburg's beacon. Light slope, this is what's called a VASI, or visual approach slope indicator. There's several different types of VASIs out there, but let's see, let's go here. Let me back up a second here. There's one thing that's peculiar about beacons. Occasionally, and maybe one of you guys can tell me, if you see a beacon rotating during the day, does it have any meaning? Like if Baraboo or Reedsburg's beacon was rotating during daylight hours, does that indicate anything?
It does.
Do you have any idea what it might be?
Bad visibility.
Bingo, right there. It's IFR conditions. When you see the beacon rotating at an airport during the day, the airport is classified as an IFR airport, which means you need an instrument flight plan to take off or instrument flight plan to land. You're going to be in the clouds. So if you ever do see a beacon during the day at an airport, and you're going to know because it's going to be overcast, and you see that beacon going around, and it's like, well, that's because the airport is IFR. Okay. So visual approach slope indicators, there's several different types of indicators. I'm going to get into all of them. I'll let you guys kind of read up on it because I'm going to keep moving here. So this is a 2-bar VASI right here. And it's got 2 near bars and 2 far bars. And essentially, the idea behind a VASI is that it gives you a visual indication of your glide path. So if you're on the glide path right here, the indication is you're going to have 2 red, lights and then 2 white lights in front of it, and you'll actually, follow that glide path down. And as long as they don't turn to both sets of reds, like this right here, the bar and the near, if they turn to red, then that means you're below the glide path. So here's our runway. I'm coming into land. Usually it's about a 3-degree glide path coming into land. So when you come in, you'll see the 2 red and 2 white. That means you're on the glide path. If they both start turning to white, that means that you're higher on the glide path. You're too high. You're going to come in steep, and your glide is not going to be as good, guaranteed. Whereas if you're low of the glide path, right here, you're going to see 2 sets of red lights or indicators there. And on the glide path, 2 red, 2 white. Now there's 4-bar VASIs. So they get into more complex, but they all do the same thing. They're designed to guide you into land. So I don't like these presentations here. I think I've got some other pictures here we can use. But this kind of shows you what you would see with a cockpit when you're looking. If you're like too low on an approach, it would the runway looks like flatter and it's kind of squashed there. If you're on approach slope, you've got this nice trapezoidal figure right here. And again, 2 reds and 2 whites here. If you're too high, now you're starting to come in higher. And you could play around with this at home sometimes. Just lay a long sheet of something out, like a runway or whatever. And if you look at it like this, it's going to, really low post down to the ground here. It's going to have this shape right here. Whereas if you look right over the top of it, it's going to look more like this. It's going to have that view. And I'll show you what it means here. Again, this is a 3-bar VASI. This is another type of visual approach slope indicator here. This is just it's got the 4 lights here, and 2 whites and 2 reds indicate you're on the glide slope. 3 reds and 1 white would indicate that you're slightly low. 4 reds would, all 4 reds would indicate that you're below the glide path. And again, here you'd have 3 whites and 1 red. You're slightly high right here. And then all whites you'd be really right there. So yeah, here's a little cross-section view of like that. There's PLASIs, which is a pulsating light indicator. Again, same principle in operation with the details on it. That's how you guys can read there. So So, yeah, here's, they've got some really complex systems, but what I wanted to show you right here was the approaches. Like this right here is an aircraft that's on the right glide slope right here. So this is coming into land in an airport. You can see the runway right there. This is what it would look like if you're on the glide path, as opposed to, let's go to some other ones here. This is a 2-mile final at 500 feet high right here. So you're too high on the final. Notice that the runway is extending out. It's a little bit longer there. Let's go here to this one. This one, you're 2-mile final and 200 feet low. And see the difference between these two? That's high and that's low. That's what it looks like. I think when you're in the plane and actually seeing this, you can, it makes sense. But there's a definite distinction in the shape of the runway between a high approach and a low approach. That's a low approach, same distance, 2-mile final. This one's low and this high. Right here, okay, and this would be extremely low right here. Well, this guy's got to be 500 feet. Yeah, 500 feet below the glide slope there. So here again, and that right there's our 4-bar VASI right there. These are all horizontal across there. You've got 2 whites and 2 reds. So this guy's right. This person right here, the pilot, is right on the approach slope for this runway right here. That's what we want to see when we come in. And what you want to do, you should strive for this in all your landings. You want to get your plane configured, and you want to get it so that you stay on this, so you're not constantly going, adding red and then also white and red. It makes it very difficult to land. If you could get this constant, then those lights stay constant the whole time, then you're going to have a smoother. So we got that let's get stuck again about final 200 feet low, again, very low, as opposed to this one, which is only that's slightly higher. So this is the difference between the low approach. Again, see how flat that is right there. This is like almost like a little flat trapezoid there. This one's a nice long there. So now we're starting to get high. Any questions on the call? So you're just to give you an idea, that's high right there. They've got the other diagrams in there, so this is some of the things. Really, it's hard to see the difference between these right here. I don't see much of a difference, but here's our precision, what they call PHAKs. So precision approach path indicator. So these are, you've got, it's 1430. In your books, 1430, we'll have this diagram. Oh, it's going to show, you don't see it there? Oh, yes, sorry about that. Yep, so that's actually, yep, sorry about that. Yeah. So it's actually 14, it's like 14, 17. Okay, thank you. So the different types of approaches there. So again, these are the 4 white that indicate you're high on the approach. 3 red or 3 white and 1 red indicates you're slightly high if you're glide slope, and 2 white and 2 red. That's what we do. But it's in some cases you might want to come a little bit lower or a little bit higher. It really depends on the conditions. So this gives you a much more precise way of analyzing, if you're high or low, if you're slightly high or slightly low. And that's called PHAK, precision from the most advanced. Tricolor, yeah. So there's these actually change in color. So obviously red, you're below your glide path. Amber or green means you're on the glide path, and then amber is your above the glide path. And notice too that when you transition from low to high on the glide slope, there is an amber color there. So you don't want to get thinking that you're slightly high when you're really just you're slightly low here. So that's one of the drawbacks of the tricolor glasses there. Pulsating lights. So this actually have pulsating lights. Um, it'll be pulsating red if you're below this little line slope there, and steady white if you're on the line slope, and then pulsating white if you're above the line slope. And again, that's a in-ground runway lights. You've seen this at night. Coming in, as a matter of fact, I think up here. Yeah, you can see these in-ground or in-runway lights. They're actually embedded in the pavement. They really make a difference coming into land at an airport. Like most small airports don't have these. The reason for where you won't see something like this. But larger airports like Madison and Milwaukee across, they'll all have these lights. And they do make it much easier to identify. We come into land at Reedsburg, we'll only see in the runway the side lights for the runways themselves. We don't see there's nothing else. We'll see the outline of the runway, but we won't see all these center lines and stuff like that. Okay, so the other thing you can do when you come into land at an airport, you can key your mic. So let's say we're coming into land at Reedsburg or Bearwood, that is. You can grab your mic and you can actually key it 7 times in 5 seconds. And what will happen is this is called pilot controlled lighting, but it'll actually bring up all the taxiway and runway lights up to full intensity. And that's really helpful when you're trying to find an airport. Sometimes it's not that easy to spot an airport. Maybe the beacon is blocked off or something like that. But if you key that mic 20, 30 miles out, it's going to light up that airport and any other airports that are on that same CTAF frequency. They're all going to jump up. And Bearwood has, I think it's for me, rails as well. So there's a term called, or an acronym, rails, which is an abbreviation for runway end identified lights. They're called rails. And those will actually, at Bearwood, they'll kick in. If you've ever driven by Bearwood at night and you've seen flashing, lights, that's somebody keyed the mic to land at Bearwood. And they usually stay on for, I think, 15 minutes or something like that. So they'll be flashing. You really notice them when it gets foggy. And reels are really nice to have because if you are in low visibility, let's say the visibility is down to like 3 or 4 miles and you're coming in at night, having those runway and identifier lights really helps you identify where the end of the runway is there. You can kick the intensity down 5 times, or I'm clicking the mic 5 times and then 3 times. Questions?
Yeah, I think it was last year. I was on a flight.
Mm-hmm.
We were coming into Madison, and it was so foggy.
Mm-hmm.
You could not see probably like 6 feet in front of you.
Mm-hmm.
And so, like with those lights, it was really nice because they must have just been clearly. Yeah, you could not see anything. You could barely see the end of the wings.
Yes, yeah, and the pilots rely on that to get down safely. They do have auto landing systems in a lot of aircraft now, but I think the airport has to be authorized for it, and the aircraft absolutely has to be authorized to be auto land. And that's where the pilots basically just let the plane come in, touch down, and does everything. Once it gets on the ground, then that's it. Yeah.
So if it is like a tower airport, couldn't you just ask the GC otherwise to
Smart.
like,
Yeah, because you bump up the intensity of the lights if you're having a hard time identifying it. There's things they can do. They actually have what are called light guns, which we talk about here in a second. They can actually aim those at you. They're very precise. They'll point this light gun at you. It projects a very strong red, green, or white beam of light toward the person there, so they can help you identify that location at the airport. So they may use something like that, but they would also consider bumping up the lights, the intensity of the lights. And they oftentimes do. If the pilot's in distress or something like that, they need to get down, they'll do that. So Johnny brought up a really good point, and this is something that is whether you're an existing private pilot or you're a student private pilot, you need to ask. ATC is there to help. They're there to provide safety in the airspace system, and they want to help. I don't know how many times I've talked to them, and they said, "I just wish the pilots would ask us more if they need help with something." A lot of times we feel like, I don't want to really talk to ATC. I don't want to bother them, but they really want to hear from you. It helps keep other aircraft safe, and it helps keep you safe. So again, ask. That's a good thing to do. And whenever you get especially if you're in any kind of trouble or anything like that, ask ATC. Don't worry about any enforcement actions. I mean, the types of enforcement actions I've seen have been, I think anyway, have been pretty light for some of the issues that FODs have done. So, but obviously, if you do something intentionally, that happens. Talking a lot of times, the ATC, they're not police. They want to help. Okay, take off whole lights. This is something that we're starting to see more and more of here. So this, as this plane taxis onto the runway right here, the lights are changed to red, indicating that they're to taxi into position and hold at that location. They'll switch to green to allow them. So it's another indicator for a pilot that it's okay to take off on the runway. Yeah.
Does it also work for lightning?
Yeah, I could. I don't know if that's what they use it for. I know it's the I think it's primarily for taking off, but I don't see guys that using that they wouldn't be able to use it for taking off or for landing as well. So again, those are just red lights there. And again, big thing with the FAA is runway incursions. They want to cut down on the number of runway incursions. So and obviously, one of the things when you're flying into an airport like Reedsburg or like, maybe a really small airport where there's no AWAS or weather service or anything like that, they may just have a windsock out there. Like Reedsburg does have a windsock, I think, over here. I think they've got a wind tee or a tetrahedron on the field as well. I think it's over there. When you take off, where you're going to leave today, if you look over on that side of the field, you might see something in the ground that's got this like big. It's huge. It's about the size of this room. That basically rotates around in the direction of the wind there. So what this is, these are various wind identification devices here. The windsock is the most common one. You may not know this, but a windsock actually has graduations on it. So it's if the windsock it'll always be pointing out. It always points in the direction that the wind is coming from. So in this case, it's the wind is coming from this direction over here. It's filling that tube up and it's blowing this up. But these are graduated right here. So like 5 knots, this right here would just be draped down. That last part of the tube there would just be draped down. So it would be 5 knots or less. And then 5 knots and 10, between 5 and 10 knots, it's going to be half inflated. So it'd be up right here, but this side would be just draped down. So that's another way you can use to kind of gauge how fast the wind is. If you don't have any weather information just coming in, and a lot of grass strips, private strips, they'll have a windsock, but they're not going to invest in a AWAS system because they cost some money there. So this is how we view it. With the tetrahedron, it's the same thing. It's pointing in the direction of the wind. So in this case, the wind is coming from this direction right here, and it's hitting it. It's just a big triangle like device, and it's like a weather vane is all this. Wind tee, same situation. It just swivels around on here. It looks like a little plane right there. It's like a weather vane. It's going to point in. This is these are traffic pattern indicators right here. This is something that you'll typically see around like a tetrahedron or a wind tee right there. So this will be out in the field someplace. We'll be actually looking down on this from above, and you'll see these white markings. Usually they're like barrels, white painted barrels, and you'll see these lines right here. What this is telling you is there's 2 runways at this location here, and it's telling you that in this case the pattern traffic for this runway is over here. That's the runway that would be in the center right here. So the runway that's running this direction, whether that's north or south, this one else doesn't make a difference. But it's saying the pattern traffic is over here, and for this runway that runs in this direction on the field, it's the traffic pattern is going to be over there. The reason they put this in there, obviously for pilots' information, but the other reason they do it is because maybe they don't want people flying over this neighborhood over here. Maybe this is a this is a runway right here, and this is a runway, but there's a neighborhood right here. So they don't want traffic flying in this area right here. So they'll fly these patterns. Normally, before you even go to an airport, you're going to look up what the pattern is for that airport. Normally, it's going to be a left-hand pattern. But like I said before, some airports have right-hand patterns. Yeah. Any questions? All right, we already talked about this. This is your, downwind right here, base leg, final departure leg, upwind, and then departure right here. So normally you would take off, you'd say, these for traffic, 264 runway, departing runway 36, departing to the southeast or southwest. And then the crosswind right there. So that's kind of what we here. So wait. I think you guys have got that. So let's go here. All right, this just describes the difference between right-hand traffic. Yeah, okay, so this is, you've got right-hand and left-hand traffic. So let's see, so this would be your left-hand traffic for this runway right here, and this would be your, I'm sorry, right? Yeah, this would be our right-hand traffic right here. This would be our left. Again, it's based on where you are in the, not where you are in the cockpit, but basically the left side of the plane here. If the runway is over in that direction, we're left here base. So this would be left base. This would be left crosswind, left down. This would be your left midfield right here. This would be right midfield out. So it's very precise. Don't worry if you don't get it right away. You're going to need to know this obviously for the practical test. But for now, just understand the left-hand traffic is probably the most common one. You just have to kind of flip it around. Okay. Phonetic alphabet. This is something you should be practicing every day. Just go through the alphabet just like you did your ABCs and start practicing Alpha Bravo. When you tell people, a word, let's say you give them a password or something like that, use the phonetic alphabet. You got to get really comfortable with this. It's really simple. I mean, it's pretty basic. The reason why we do this, we have this pronounced phonetically, is because in the aircraft, radios have static. There's other kinds of issues with them. We can't always make things out. But if I hear somebody say, all right, turn on to taxiway ISKI, then there's no other letter that has ISKI in it other than whiskey. So what they're trying to do is they like certain letters like S and F, they sound very similar, especially if you're on the phone with somebody. So by spelling out Foxtrot, that sounds totally different than Sierra. So S is Sierra and F is Foxtrot. So it's very simple. That's why we use phonetic pronunciation, because we want it to be very clear communications. And the other part of that is, there's no part of one of these words that sounds like another part of another word. They all have, two parts to them that for the most part, will help you prevent, if there's a little bit of static and you don't hear, ya and Yankee, but you hear Yankee, you'll know that it's Yankee. Okay, that's what they're trying to do with this. Now the numbers, very simple. We have 1, 2, 3, or tree. A lot of times we want to say 3, but the proper pronunciation, phonetic pronunciation, is tree. So air traffic controllers will always say tree for 3. A lot of pilots, including myself, sometimes they just say 3. But the proper pronunciation is tree for 3. Yep.
So do you have to be able to identify an air traffic controller if they say tree, or like they use tree? Or?
Yeah. If somebody says that, if they're giving you some numbers over the phone or something like that, they say trade, you know that they're probably a pilot or a traffic controller. So, okay, 4 is 4, 5 is Fife. Again, I just use 5, but it's Fife is the actual pronunciation for it. Most pilots just use 5, but again, it's the proper pronunciation is 5. 8 is 8. Niner, crawl familiar with Niner. We've heard that before in movies and stuff like that. So, so 9 is Niner. Okay, so again, you've got it. What they're trying to do is prevent you from, you know, from any of these never sounding like something else. So they always have the different pronunciations. Okay. All right. So this has to do with the light gun signals. So let's say your radio goes out, and you're coming in to land at an airport. What they can do if you can get their attention, or if they know that you're inbound, but all of a sudden your radios go dead, your power, your battery blew up or something like that, they can actually direct a light gun at your plane, and they can give you instructions with the light gun. You need to know this for the FAA test. You need to understand how this works. So it makes sense. You know, when you think about it, you've got red and green and white. They all have specific meanings. Green would make sense. It means go, right? Continue, right? Red means stop or danger. Okay. Flashing green, you know, that has a certain meaning. Flashing red is even more so, you know, important than just a regular steady red. So it's like think about cops, you know, red flashing lights. It's unsafe. So essentially, how it works, it depends on what portion of flight that you're in. So if you're on the ground, normally you're going to go up to the tower cab or to call them and say, hey, look, I don't have a radio. I've got to get out of the airport. Can you guys give me light signals so I can depart the airport safely? And at that point, then you would go ahead and start up your aircraft, and you'd look to the tower cab, wherever it's at. And if you saw a steady green or a flashing green, that means that you're cleared to taxi. All right, and you keep glancing at that light there. And if they wanted you to stop or hold short of the runway, it would be a solid red. And again, they've got this gun. They just point right at your aircraft. It's a very intense beam of light. You can't miss it. It'll be, you know, solid red. That means you're going to stop. Flashing red, taxi clear the runway, and you want to get away from the runway that you're at. Flashing white, return to their starting point at the airport. It means you got a taxi all the way back to where you started from. I want to talk to you or something like that. Alternating red and green just means exercise extreme caution in all flight conditions there, whatever, whether you're on the ground, flight or whatever. All right, so that's when you're taxiing out to the runway. Cleared for takeoff is just a solid green. So if you see that, you're good to go. Green light, you can take off. Okay, aircraft in flight. So this might be more problematic because they may not see you. You get their attention by flashing lights. And again, this would be a situation where you've got an emergency, you need to get down, and you can't communicate with them. So you want to do whatever you can to get their attention, and then they'll grab that light gun and they'll start using it. So in that case, if they just say, all right, you're cleared to land, I mean, obviously the tower thinks, look, this guy's in trouble, there's nobody around the airport here, I'm just going to give them a green light. They'll actually aim that gun at you, that light, give you a green light to land. Or they may say, in return for landing, this is a flashing green here, return for landing. See that? Steady red obviously should be a caution to you, give way to other aircraft and continue circling. Flashing red, they're telling you airport is unsafe, don't land. That's the most critical one. If you see that, then obviously there is, you got to pay attention to the area. So there's nothing for aircraft in flight for flashing reds. Then again, red and green just exercise extreme caution. Again, you do need to know those for the test. All right. Okay, radar beacons. They are, we'll just finish this. I think I'm done with this chapter here. So, we've actually gone over vortices, so there's much we have to do there. So, a transponder is a device that is in the aircraft. And what it does is It's a transmitter and it's also a receiver. You've got a radar beacon at some airport. Let's say this right here is my radar beacon right here, and it sends out a radio wave. It just swings around. We've all seen the pictures of the radio or radars that are working. They've got the sweeping arc there. When that arc hits the aircraft, there's a little receiver in there called a transponder. It gets that signal that a radar beam passed through it. And what it does is it sends back a ping to the radar facility saying, my transponder number is this. That's called a squawk code. And we enter the squawk codes into into the transponder by using either knobs or got a push button, whatever, and type that number in. They'll give you a squawk code. They'll say squawk 0412 or something.
Did we talk about squawks that you started everything all that?
We may have. Yeah, do you guys remember us talking about squawk
A
codes?
little, like if you're,
We've
have
had
something
something
that there's like if somebody's on board or something, have a certain spot code.
Yes, yeah. There's specific squawk codes for those. Yeah,
Yeah.
squawk for VFR and hijacking. Yep. So the squawk is so if they say squawk, VFR, they want you to squawk 1200. That's the code for VFR traffic, and you would turn in your transponder to 1200. Or if they said squawk 0405 like that, you'll turn that into your transponder, and then your transponder is going to be pinging that back to that radar. Now keep in mind, we've got a lot of radars around. We've got Fullfield, Ross, Madison, Milwaukee. Sometimes can reach out as far as here, depending on who are up. But your transponder is receiving all of those things, and it's constantly sending out all those squawks, those things, and what your number is up here. So they'll use things like squawk standby, so you'll switch your transponder to standby. Squawk roll normal, you don't see that very often. Squawk altitude, that means your transponder should be set to mode C. There's a little switch on your transponder set to altitude or mode C. Stop squawks, which that means just turn your transponder off. Squawk mating, which would be 7700. That's the number that we turn into the transponder. And what that does is it lights up their radar display instantly. It tells you, okay, this is the guy we want to focus on. It'll also notify anybody else that has radar traffic that's looking at your airplane. It'll light up on their displays that there's a maybe situation there. You get squawk VFR is just 1200. So that's the different codes there for squawking. Let's see. Yeah, this is basic stuff. Traffic advisories. They always give your traffic advisors. So they'll say to this aircraft, they'll say United 31 Heavy. You've got traffic at your 12 o'clock, 2 miles opposite direction. So, but notice how the plane here is flying in kind of it looks like it's crab, but it basically is compensating for the wind here. So the heading or the heading of the plane itself is pointing up here, but the actual track is this way. The air traffic controllers do not know where your plane is pointed at. All they know is your track across the ground. So if the wind is coming strong out of this way, I'm flying in that direction. I've got to compensate for the wind right here. So I'm turning my aircraft in this direction. My heading might be that way, but my track is this way. That's the information they're giving you, so that you have to be aware of that.
Would that be called slipping?
That's slipping. Yeah, that's something that'd be different because the slipping, you're actually, you're twisting your aircraft around and you're actually losing efficiency by the way you're doing. Which all you're doing is like a canoe. When you're going across a river, you're just pointing the canoe up the river and cutting across the width of the river there. But you're not actually civil way. You're not your rudder is not on the canoe. If you had a rudder on the canoe, you wouldn't have it constantly turning. It would just be inefficient. So you just point the canoe up the river, the ship up the river. All right, then this other stuff, the wingtip vortices, we already talked about that, so we don't need to cover that. Let's see here. Yes, again, we talked about this before, runway crossing, runways and stuff like that. This is an example of a plane that crossed the runway threshold line right here. You get a big jet coming in, obviously. When they tell you to hold short of a runway, they mean hold short of the runway. Anything past that is a runway incursion, and they're really sticky about that. There's been a number of high-profile accidents because pilots broke that simple rule. Okay. Yep. That. And then communications. We'll talk a little bit more about this here again. So, they talk about this called AMAS. Yeah, this is this stuff right here is it's a what they call it. Something mass. EMAS, yeah. Okay. So it's basically it's an arrestor pad for jets when they come in. If they overrun the landing portion of the runway and they go off, that's what this happened here. This either something happened, they've lost their brakes or something like that. The pavement is designed to break up and not cause as much damage to the aircraft, but it slows it down really fast. It's very effective stuff. Creates a lot of friction, yep, and it slows the aircraft down. So if there's an incident with the brakes, or maybe the pilot couldn't land in that time, then it's going to sink into it and it's going to slow down.
So it'd be on Europe for the prepared hospitals, or at the airport just.
What's that? Oh yeah, we pay for it. That's a good question. Yeah, if they're at fault, it would make sense that they would have to pay for it. But I never had to use myself. So. All right. So next week, you guys, we're going to do airspace really briefly, and then we're going to dive into navigation, and then we do aeronautical. Start working on your E6B computers. Those slide rules. Start reading the manuals that came with them, because we're going to fly through that next week. Now we won't have a whole lot of time. Next week should be our last meeting. If we need to, we can always schedule another one too. Yeah, let's see. Did you let me know if you want to do the flight sim sometime too? Because this week is a little bit better for me. So. Okay. All right. We're good. Yeah. I'll keep in touch. I almost got the plane done this week, but we delivered 3 simulators, so I was busy with that. So I'll definitely get you going for yourself. You take care of that. Thank you.